Alright, let's work on graphing linear and quadratic systems. Wow, look how far we've come. Next slide. Next slide. Next slide. There we go. Alright, as you might remember, we can solve systems by graphing. Here we have two linear equations. We've got y equals 3x minus 8, so I know my y-intercept is going to be at minus 8. My slope is positive 3. 1, 2, 3 over 1. 2, 3 over 1. Look at this. You can just 1, 2, 3. Oh my goodness. You can just keep that rolling. That's going to form a straight line. I don't even know if I would. Can I try it? Yeah, look at that. Not so bad. Okay. So we've got y equals 3x minus 8. X plus y equals 4. So I know that if my my y-intercept is when x equals 0, so I know 0, 4 is going to be on there, and 4, 0 is going to be on there. If I plug those in, well, let's use a different color. Look at that. Magic. Go from there to there. I think my solution is going to be right there, where they both cross and they hit. So my solution for this system by graphing would be 3, 1. Should be used to that. Be on top of that by now. But how can we do a quadratic and a system? Let's check that out. So a linear quadratic system is formed by a linear equation and a quadratic equation. And those things are going to have either two solutions here, boom, and boom. This would be a two-solution graph. Here there's one solution. So it does range. There might be 2, 1, or 0. This green line and this red line, they're never going to cross. This is an exponential growth, so it's just going to barely move to the left and just going to keep going forever. Whereas this green line, it's not getting any further to the right than that. This is 0 solutions. Look at that little circle. It's got looks like an octagon. Good stuff. All right. Oh, there's children outside knocking on the door. Solve by graphing. So when we're doing this, we're going to graph both equations on the same coordinate plane, and we're going to look for the points where the graphs intersect. Shouldn't be too bad. So let's solve by graphing. I think that for my own sake, I'm going to start with my linear one here, because that should be pretty easy. My y-intercept is at -1. That's when x equals 0. 0 minus 1 is -1. And my slope is -1 over 1. So I'm going to go in a downward here. Let's see if I can do this. That looks okay. Something like that. But my quadratic isn't going to be as easy to solve, but we should know how to do that. Let's start with the vertex here. I want to do my -b over 2a for my x value. -4 over 2 times 1 is 2, which should be -2. That's my x value. My y value, I'm going to plug in that -2, -2 squared, plus 4 times -2 plus 3. That's going to be 4 minus 8 plus 3. -4 plus 3, -1. I think that my vertex is at -2, -1. Should be right about there. Okay, that's going to be my vertex. I know it's going to be a positive parabola, so it's going to go up from there. Let's find our roots. I think that's going to be helpful. So we're going to solve for x. Can I do it by factoring? 1 times 3 is 3. 4 on the bottom, +3, +1. My a value is 1, so I can jump to x plus 3 times x plus 1 equals 0. So my solutions, or my roots, are going to be -3 and -1. That would put me right here and right here. I already have a solution point right there. As you can see, that green and the purple are going to cross each other. However, because it's a positive parabola, I think I'm going to get one more on the left side. Probably around like -4, it looks like. So let's check that out. How about if x is -4, y equals negative 4 squared plus 4 times negative 4 plus 3, 16 minus 16 plus 3, just cancel out. I'm at positive 3. I think if I had drawn my purple line a little bit better, that parabola would cross right there. Those are going to mirror each other. Those would be here. Okay, so my solutions for this problem are at, looks like the x-intercept there, negative 1, comma 0, and as well as negative 4, comma 3. Negative 4, comma 3. So we're just graphing and finding where those points intersect. Let's go to another example. Four x minus 2y equals negative 6, and our quadratic on top is y equals x squared plus 2x plus 3. I'm going to start with this is in standard form, so I'm going to subtract 4x from both sides, leaving me with negative 2y equals negative 4x minus 6. Divide everything by negative 2. Y equals 2x plus 3. That means my y-intercept is here, positive 3. And I'm going to go up 2 over 1, down 2 over 1. And I'm going to try and do a straighter line this time. That should be fine. And let's go to our next example here. Y equals x squared plus 2x plus 3. So let's find our vertex. Negative 2 over 2 times 1 is 2. So this is negative 1 for my x value. Let's plug that in. Y equals negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is 1, minus 2 plus 3. Negative 1 plus 3 is 3 minus 1 is 2. So my vertex should be at negative 1 and 2. Negative 1 and 2 right there. Doesn't really cross over. Negative 1 and 2. Sorry, I'm getting knocks at the door. Alright, and let's find another point here. Probably our x-intercepts would be a great place to start. Can we factor that? Let's see here. Positive 3 adds to 2. Positive 3 adds to 2. 3 times 1 would be 4 there. And 1 times 3 can't have negative, 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 wouldn't work. Alright, so we might have to use the quadratic formula or another version of this. You could also complete the square, whatever you thought would be best for you. I think I'll complete the square on this one. Why not? Let's do x squared plus 2x equals negative 3. Divide my b value by 1 or by 2 and square it. 2 over 2 x squared plus 2x plus 1 equals negative 3 plus 1 is negative 2. X plus 2 squared, and that equals negative 2. I see what's happening here. This is a positive parabola. It's not going to have an x-intercept. So we're going to have to go a different direction here. Let's try the y-intercept. Y equals 0 squared plus 2 times 0 plus 3. 0 plus 0 is 0 plus 3. And I think we have a solution point right here. The question is, are we going to have more than one? Let's check number 1. We're running out of space here. As you know, always hard. So let's try 1. If we fill in y equals 1 squared plus 2 times 1 plus 3. 1 squared is 1 plus 2 plus 3 is 6. So 1 will be 6. So I think that we can safely say that there is one touch point here for this parabola and this solution, and it's at the y-intercept. So there's just only going to be one solution here, and that is at 0, 1, 2, 3. All right, there we go.